So hey, in our last video with the calculator, we saw that this is another notation that means taking the derivative, taking the derivative with respect to x of this function. So I am going to use my limit as h approaches 0 of f of x plus h, which is 1 over x plus h squared minus 1. Minus f of x, 1 over x squared minus 1, all over h. So as h goes to 0, this is an indeterminate form. So I need to simplify this crazy rational expression. So here I can get some common denominators. X plus 1, x plus h squared is the first denominator. So I'm going to multiply, or minus 1, so I'm going to multiply this by x plus h squared minus 1 on top and bottom. And then this one is going to be multiplied by x squared minus 1 on top and bottom, but I'm not showing that work. So I have the limit as h approaches 0 of x squared minus 1 subtracting x plus h squared, and then if I distribute the negative again, that's plus 1, all over my common denominator, which is x squared minus 1 multiplied by x plus h squared minus 1. And then since that's all being divided by h is also in my denominator. So first thing I see that happens in my numerator is these ones cancel. I want to expand this binomial, so I have x squared subtracting x squared plus 2xh plus h squared. And this is all over my common denominator multiplied by h. So now I see that my x squareds cancel, and everything in my numerator still has an h, so I'm going to factor that out with this negative. So I have the limit as h approaches 0 of negative h multiplied by 2x plus h all over my common denominator multiplied by h. So now these h's cancel. I'll go up here, and I'm left with the limit as h approaches 0 of 2x plus h negative over x squared minus 1 multiplied by x plus h squared minus 1. So as h goes to 0, my numerator becomes negative 2x. And my denominator, if this is 0, this is x squared minus 1 multiplied by x squared minus 1, x squared minus 1 squared, which is dx, the derivative with respect to x of our original function. So our properties of limits come up quite a bit.